Hello everyone. Welcome to Hydropower. Today we will be discussion about stage of hydropower development. So the stage of hydropower are 1. Reconnaissance stage. 2. Pre-Feasibility Studies stage. 3. Feasibility Studies stage. 4. Detail Engineering Design stage. Now let's start with the 1. Reconnaissance stage. This is the initial phase in the process of assessing the feasibility of developing a hydropower project. It involves gathering preliminary information and conducting a high-level assessment to determine whether the project is worth pursuing further. The primary objectives of the reconnaissance stage are as follows. Resource identification. Identify potential water resources that could be harnessed for hydropower generation. This includes assessing rivers, streams, and other water bodies that may have adequate flow and head to generate electricity efficiently. Preliminary site assessment. Conduct a rough evaluation of potential dam and reservoir locations, as well as potential power plant sites. This involves considering factors such as topography, geological conditions, and accessibility to determine the viability of these sites. Hydrological studies. Gather data on historical flow rates of the water source to estimate the available water resources throughout different seasons. This data is essential for determining the potential energy output of the hydropower plant. Environmental and social impact assessment. Conduct a preliminary assessment of potential environmental and social impacts that could result from constructing and operating the hydropower project. Also identifying potential ecological disturbances and impacts on local communities. Economic and financial analysis. Perform a rough cost-benefit analysis to evaluate the economic viability of the project, estimating the construction costs, potential energy output, expected revenue from electricity sales, and an initial assessment of potential return on investment. Regulatory and permitting assessment. Identify the legal and regulatory requirements for developing a hydropower project in the specific location and understanding the necessary permits, environmental clearances needed to proceed. Stakeholder consultation. Engage with relevant stakeholders, including local communities, government agencies, and environmental groups, to gather initial feedback and identify potential concerns. Technical constraints and opportunities. Identify technical challenges that may arise during the development and operation of the project and look for opportunities to optimize the design and maximize energy generation. 2. Pre-Feasibility Studies stage. The pre-feasibility stage of hydropower studies is the next phase in the assessment process following the reconnaissance stage. It involves conducting more detailed investigations and analyses to evaluate the technical, economic, financial, social, and environmental aspects of the proposed hydropower project. The primary objectives of the pre-feasibility stage are as follows. Hydrological studies. Gather more comprehensive data on the hydrology of the water source, including long-term flow patterns, seasonal variations, and extreme events. This data is used to develop more accurate energy production estimates and assess the project's reliability. Topographical surveys. Conduct detailed surveys of the proposed dam and power plant sites, as well as the surrounding area.
This information is vital for engineering design and assessing the potential impacts on the landscape. Geotechnical investigations. Assess the geological conditions of the proposed sites to understand the stability of the terrain and potential construction challenges. Environmental impact assessment. Conduct a more thorough EA to identify and assess potential environmental impacts and analyzing the effects on ecosystems, biodiversity, water quality, as well as other environmental factors. Social impact assessment. Conduct a more comprehensive SIA to understand the potential social and cultural effects of the project on local communities, including issues related to resettlement, livelihoods, and cultural heritage. Technical design and engineering. Develop a preliminary engineering designs for the hydropower plant, dam, penstocks, and other necessary infrastructure, which involves optimizing the design for efficiency, safety, and cost effectiveness. Cost estimation. Conduct detailed cost estimation for the construction, operation, and maintenance of the project, and analyzing various cost components, such as civil works, hydro-electromechanical equipment, transmission lines, and contingency allowances. Financial analysis. Assess the financial viability of the project by estimating the cash flows, calculating the net present value, internal rate of return, and payback period. This analysis helps determine whether the project is financially feasible. Market and power offtake studies. Analyze the potential market demand for electricity and identify potential buyers or off-takers for the generated power. Risk assessment. Identify and analyze potential risks and uncertainties associated with the project's development, construction, and operation. Permitting and regulatory compliance. Continue the process of obtaining the necessary permits and environmental clearances required for the project. 3. Feasibility Studies Stage. The feasibility stage of hydropower studies is the most detailed and comprehensive phase in the assessment process. Its primary objective is to determine whether the proposed hydropower project is technically, economically, financially, socially, and environmentally viable. It involves a systematic examination of all aspects of the project and requires in-depth analysis and data collection. The key components of the feasibility stage are as follows: detailed technical design. Prepare highly detailed engineering designs for all project components, including the dam, power plant, penstocks, turbines, generators, transmission line, and other infrastructure. Environmental and social impact assessment. Conduct a comprehensive EIA to systematically assess the project's potential environmental and social impacts, and analyzing potential mitigation measures to minimize adverse effects. Detailed cost estimation. Refine and finalize the cost estimation for all aspects of the project, including capital expenditures and operating expenses over the project's lifetime. Financial modeling. Develop detailed financial models based on the refined cost estimates, revenue projections, financing options, and other financial parameters, and determine the project's financial viability as well as risk analysis. Market analysis and power offtake agreements. Conduct a comprehensive analysis of the electricity market, power demand projections, and secure power purchase agreements with potential buyers or off-takers. Resource assessment. Conduct detailed assessments of the available water resources, considering seasonal variations and flow variability, to accurately determine the hydropower plant's energy production potential. Geotechnical investigations and risk assessment. Perform comprehensive geotechnical investigations to assess the stability of the dam foundation, powerhouse foundation, waterways, and other critical infrastructure. Additionally, conduct an extensive risk assessment to identify and mitigate potential risks and uncertainties. Regulatory compliance and permits. Ensure all necessary regulatory approvals and permits are obtained for the project's construction and operation. Socioeconomic studies. Conduct detailed socioeconomic studies to understand the project's impact on local communities, including issues related to resettlement, employment opportunities, and local development. Project scheduling. Develop a detailed project schedule, including construction timelines and the expected commissioning date. Project organization and management. Establish the project organization and management structure, including identifying key project stakeholders and defining the roles and responsibilities. 4. Detail engineering design stage. This stage is a crucial phase in hydropower studies following the feasibility study. During this stage, the hydropower project's design is finalized with careful attention to technical specifications and construction plans. The primary objective is to produce comprehensive engineering documents that serve as a blueprint for the construction and implementation of the hydropower project. The key components and activities involved in the detailed engineering design stage are as follows: finalizing technical designs. Based on the findings of the feasibility study, engineers finalize the technical designs of all project components, including the dam, intake structure, spillway, powerhouse, penstocks, turbines, generators, transformers, and transmission lines. Civil works design. Detailed engineering plans are developed for all civil works, such as the dam, spillway, waterways, powerhouse, and various support structures. Geotechnical investigations are used to ensure the stability and safety of these structures. Hydroelectro, mechanical, and electrical design. Detailed mechanical and electrical designs are prepared for the project, including the layout and specifications of penstock turbines, generators, transformers, and other equipment. Hydraulic design. Engineers perform detailed hydraulic analysis to ensure efficient water flow through the penstocks and turbines, maximizing energy conversion. Control and automation systems. The design of control and automation systems for the power plant is finalized to ensure seamless operation and monitoring. Environmental mitigation measures. Detailed plans for implementing environmental mitigation measures, as identified in the environmental impact assessment, are incorporated into the engineering design. Safety measures. Comprehensive safety plans are developed to ensure the safety of workers during construction and the operational phase of the project. Detailed cost estimation. An accurate and detailed cost estimate is prepared, including quantities of materials, labor, and equipment needed for the construction. Procurement planning. A procurement plan is created to outline the sourcing and purchasing of equipment, materials, and services required for the project. Construction scheduling. A detailed construction schedule is developed, breaking down activities into specific phases and timelines. Quality assurance and quality control. QA/QC plans are formulated to ensure that construction and installation adhere to the highest standards and specifications. Environmental and social management plans. Detailed plans for managing potential environmental and social impacts during construction and operation are developed. Permitting and regulatory compliance. Ensuring all necessary permits and regulatory requirements are in place for construction and operation. Stakeholder engagement. Ongoing engagement with stakeholders, including local communities, to address concerns and ensure their involvement and support throughout the project. Thank you. See you in next video.